Algebra 2 Module 3 Test Preview. In Algebra 2 Honors, we're going to be having a test next week. And in this test, the topics that will be tested are these: characteristics of quadratic functions such as axis symmetry, vertex, minimum, maximum values, increasing, decreasing intervals, domain, and range. Writing a quadratic function vertex form, given a quadratic function in standard form by completing square. Projectile motion problem. That's going to be like a rocket function problem. And then finding an approximate quadratic function given plotted points. Find a quadratic function given a vertex and one other point. If a quadratic function opens up or down from a given vertex, can other points possibly lie on the graph of that function? Write a quadratic function for a parabola that has a given axis symmetry and two more points. And then we'll have a suspension bridge between two towers problem. And so in this preview, we're going to go over most of these things. Okay, choose true or false for each statement about the function h of x equals 20x minus 3 squared plus 4. The axis symmetry is x equals negative 3. Well, the standard form is this: h of x equals a times x minus h squared plus k. Well, if we have axis symmetry is h, so h equals our axis symmetry. So x equals negative 3. So if we substitute in for this thing right here, negative 3, we would get x minus negative 3, which translates to x plus 3. So therefore, this does not match axis symmetry of x equals negative 3, so this first one is false. The minimum value is 4. We have an upward opening parabola. So this would be our minimum value, and that is 4. And you could graph this in a calculator and see that is the case. So this second statement is going to be true. The minimum value, the maximum value is negative 3. Well, in a quadratic function, you can't have both a minimum and a maximum. So if there is a minimum value, there is not a maximum value, so that is going to be false. Next, the function is increasing on 3 to infinity. And if we have our parabola opening upward from 3, our axis symmetry is 3, that would be true, because you would have at 3 comma 4 is where we would have our vertex, and from x equals 3 to infinity we would be increasing. So this is true. And the last statement, function is decreasing on negative infinity to 4, that is going to be false. Next, identify the domain and range of the function f of x equals negative 20x plus 4 squared minus 5. And I'm giving a lot of liberty here as far as in which notation to use. So in interval notation, the domain of any quadratic function is all real numbers. So domain is going to be all real numbers, which we can articulate as negative infinity, comma infinity. And are we opening upward or downward? So this negative sign in front means opens down. or downward. So that means that this value here, our vertex is going to be the coordinate pair -4, comma, -5. And since we're opening downward, this has to be our range is going to be greater than -infinity all the way up to a maximum of -5. And lest we had another thing about this -5, how do we write that? We're actually included at -5, so we can bracket that off. And yes, we can graph this in the calculator if we have one. Negative. We have x. Let's see if that's going to be +4 squared -5. -5. Graph. We have a maximum here at maximum of -5 at x equals -4. And you could trace to see that that's the case. We could go to the table view. We see where x is. Where is that thing? Let's try that again. Second trace. There we go. Where x is -4, we have a maximum of -5. Okay. So these would be our answers for this one. Remaining range. Next problem. Write the quadratic function of vertex form by completing the square. Now here we have x squared to the first power. We're going to rewrite this as f of x equals. We'll have a parenthesis here, x squared minus 8x. And we're going to have plus some number we don't know. And outside of this parentheses, we're going to subtract that same number, these two numbers here, at which the arrows are pointing each way, are going to be equal to each other, and then we bring down this +3. All right, how do we get the number that goes in here? Well, it's going to be by taking this -8, taking half of that, we get -4. And then we square this number, -4 squared equals 16. So 16 will go here, -16 will go here, and this is a perfect square here of pointing x -4 squared. And then we bring down what we have left, which is -16 plus 3, which is -13. And as one last correspondence, we can go to our graphing calculator, x squared minus 8x plus 3. X squared minus 8x plus 3, and we graph this function. This is what we get. And I can't see the whole thing exactly, no matter. We come back here and put quantity x minus 4 squared, and we have -13. I think that's the same thing. So we should have the red one tracing right over the blue one if we are correct here, which we are. And we go to table view, we can see that they are both the same. So this would be our correct answer right here. Next, write the quadratic function vertex form by completing square. Just go ahead and do this and follow along to see if you got it right. Okay, so we have f of x equals x squared plus 10x plus some number and minus that same number and put minus 9. Well, let's go take care of that 10x was 10 divided by 2, 5. And then below this 5 squared is 25. So we have 25 minus 9. So we're going to have f of x equals 20x plus 5 squared minus 9 is going to be negative 18. Yeah, and I'm not going to check that one. Okay, next. The following functions have either a maximum or minimum value of 5. In this case, we're given, we can do these in a number of ways. I'm gonna just take the first one and complete the square on it to see if we have a, that's going to be if our k value is 5, okay, that's going to be right. So if we take this first one and we rewrite this one as f of x equals, we have x squared plus 8x plus some number here and minus that same some number here, and we put plus 21. So what we do to get this term here, we take 8 divided by 2, which equals 4, square that 4, so we're going to have 16, and outside we have minus 16. Well, we're going to have 20x plus 4 squared, but the more important thing for the question is negative 16 plus 21 is going to be plus 5. So, yes. The following have you? Yes. This one is a yes. The first one, f of x. The other two, we can just, I'm just going to go to the graphing calculator. X squared minus 6x plus 2. X squared minus 6x plus 2. So that's not going to be that's going to be negative something. So that's not going to be right. So this will be a no here. Then negative x squared plus 4x plus 1. Let's look at that. Negative x squared plus 4x plus 1. Graph this. Looks like we have a maximum of 5. Let's go to the table view. Okay, looks like that maximum is 5, according to the table view, where x equals 2, y equals 5. So this third one here would be yes. Next problem. A rocket is launched upward at a speed of 192 feet per second from a platform 6 feet above the ground. Find the rocket's maximum height in feet, the number of seconds required for the rocket to reach maximum elevation. For this, we have to know, and you're going to be given this if you don't have it already, that when you have projectile motion in feet, what you have h of t equals negative 16 t squared plus v sub 0 t plus h sub 0. So initial velocity, initial height. So your equation is going to be h of t is equal to negative 16 t squared, and we're going to 192 feet per second, so plus 192 t plus 6. And from here you can complete the square, or if you want to, you can say, I don't want to complete the square. I can just graph this in the calculator and trace the thing to see that maximum height time. But when you get your vertex is going to be the time. So time, comma, height. That will be what our vertex looks like. So some of these answers will make sense. So you're going to have the height will be the first one. So let's find that vertex. We can complete the square as we've done in the past. Now, one thing I did is instead of completing the square in this one, I'm going to do something a little different. We have the axis of symmetry formula x equals negative b over 2a. In this case, a is equal to negative 16 and b is equal to 192. So in this case, x is equal to negative, we'll put 192, that's b, right, over 2a. So it'll be 2 times negative 16. So we have negative 192 over 32. So I'm going to put, that's going to cancel out. So I'll put 192 divided by 32. And how many times is this going to go in here? Let's see. 1, 2, 3, 4, 5, 6, is it? Well, we'll try that. 6 times 2 is 12. 6 times 3 is 18, plus 1, 2. So, 6 seconds. So, number of seconds required to reach the maximum elevation, that's going to be our vertex. So we know already we have 6 seconds. So that's our second part to this question. Next, the rocket's maximum height in feet. We can say h of 6 equals negative 16 times 6 squared plus 192 times 6 plus 6. In our calculator, we can do it this way. H of 6 equals, and I've done this quite a bit in the class, so we can get to a calculator page, and we can press 6 storage x, and then we just type in the equation, negative 16x squared plus 192x plus the initial height, which is 6 feet. So we get 582 feet. So height in feet is 582 feet. Another very easy way to do this Go to your calculator. Go right here. I'm going to clear out these functions. We have negative 16 x squared plus 192x plus 6. We know we're going to have it quite high, so I'm going to just take the window out here. I think we're going to go to 15 for maximum height. So 582 feet. Let's go to 600. They'll tell us we're going to Y scale it maybe by 8. Let's see what's going on here. Graph. So we get that little thing. Find the maximum we can trace. If we just go to trace, we can get to the very top. And we can see that top is right around 6 seconds, 582 feet, or second trace maximum, which is 4. It says left bound. We can go to the left, make sure we're to the left, press enter. It says right bound, go to the right of the vertex, we press enter, enter. So yes, at x equals 6 seconds, we have a height of 582 feet. Check, check. Okay, quite easy. Many different ways to do this. Next, we're going to take find approximate quadratic function model for the graph data by estimating coordinates of the vertex and using one other point. Well, right here, it looks like our vertex might be the point 3, negative 2. And then one other point. Well, we have a lot of other possibilities. And on this and one other type of problem where you're going to be looking at points, I'm going to be very liberal in terms of what I esteem to be a correct answer. If the function pretty well matches the points, that's going to be a correct answer. So we can go to get one other point. I don't know which one we want to get. I'm going to take this other point. I'm going to take this 7, 1, so other point. We'll put 7, 1. And so now we can find a quadratic function. We'll take f of x equals a times x minus h. So we'll put x minus 3 squared plus k. So we put minus 2 here. We need to figure out what a is. So what we'll do is set 1 equal to a, and we're going to have 7 minus 3 squared minus 2. And so what we have is 7 minus 3 is 4, and 4 squared is 16. So 1 equals 16a minus 2. And if we add 2 to both sides of this equation, we get 16a equals 3. So a is equal to 3/16. And then, so our quadratic function is going to be f of x equals 3/16 quantity x minus 3 squared, and we put minus 2. And we could try putting our different points in here just to test, see how this fits. Well, I'll just go to the calculator. So we go here. I'm going to go to Stat, Edit, and we have L1, L2. So I'll just put in the values here: -2, enter -1, enter 0, enter. Oops. Actually, it's 1. 1, enter, 3, enter, 5, enter, 7, enter. We come over here to the right. 3, 1, negative 1, 3, 1, negative 1, negative 2, negative 1, and the last one is 1. So we've entered everything. If we go to y equals, make sure our plot is turned on. We have that. We press graph. This is what thing looks like. We can't see it. If I go to the standard zoom 6, that's what the thing is going to look like. And we figured out the equation was, make sure we remember it here, 3/16 quantity x minus 3 squared minus 2. So let's do that. So put in 3/16 alpha y equals enter. 3/16 times quantity x minus 3 squared. And we are subtracting 2. Let's see how this fits. It's pretty well, right? So that's going to be quite a good fit. May not be exactly. We know the vertex in the 7, 1 should fit exactly, because those are the ones we use. The other ones, we'll see how close they are. Second table. So the first one we have is negative 3, negative 2. Yeah, so not exactly the same. Negative 1. Okay, that one, the second one fits. It's 3, 1, negative 1. That's not exactly the same. And 3, negative 2 should fit exactly. And 7, 1 should fit exactly. So not exactly, but pretty good. So we have enough that we'll be able to sketch. So I'm not looking for perfection in the sketch either. So going down and coming like this. So we have axis symmetry here. So that's going to be the point 3, negative 2, and axis symmetry x equals 3. Okay. Let's go on to the next problem. A given parabola has a vertex at negative 3, 2, and another point at negative 1, negative 3. Write the parabola's quadratic function in vertex form. Well, again, we have our standard form. Our vertex form is f of x equals a times quantity x minus h squared plus k. And our vertex is going to be h equals negative 3, and k is equal to 2. So we're going to have f of x equals a, which we do not yet know. We have x minus h, which is minus negative 3, squared plus 2. And that simplifies with this x minus negative 3. That's going to be x plus 3 squared plus 2. And the last thing we're going to do is substitute in negative 1, negative 3. So we'll say at negative 1, negative 3, we have negative 3 is equal to a, which we do not yet know. We're going to have x, which we do know, which is negative 1, minus negative 3, which is going to be plus 3, squared plus 2. So we get negative 3 equals a. Well, how many a's do we have? Well, we have negative 1 plus 3 is going to be 2, and 2 squared is 4. So we get 4a plus 2. And solving for a, if we subtract 2, we get 4a is equal to negative 5. And working to the right, we divide both sides by 4. We get a is equal to negative 5/4. So our equation is going to be f of x equals negative 5/4. We have quantity x plus 3 squared plus 2. And the last thing we can do is check in our calculator. So here's our calculator. We have negative 5, and down in the denominator 4. We're going to have x plus 3, and then we have, what is this thing going to be over here? Is this plus 2 in here? Make sure, plus 2. Calculator again. Plus 2. So it should match here. So we graph function. This is what our function looks like. Is it going to match our points? We have to have negative 3 comma 2 looks good. What was the other one? We have negative 1 comma negative 3. So let's just go ahead and check our table view. So negative 2, negative 3 comma 2, right? Negative 3 comma 2, does that match? Yeah. So that's our vertex, and we have negative 1, negative 3. That matches 2. So here's our vertex at negative 3 comma 2, and then we have our other point at negative 1 comma negative 3. Check. So this is a correct answer. Next, find approximate quadratic function model for the graph data by estimating the x-intercepts and using one other point. Well, I'm going to estimate my x-intercepts here. It looks like we have one here at, we'll call it x is equal to negative 2. And it looks like we have another one here at x is equal to 4. And do we have one other point? Yeah. This vertex here looks pretty solid. Looks like the point 1 comma 5. So let's go ahead and work that. Again, when you actually do this one, I'm going to be very liberal about an equation that is close to this. But to find our factored form, we have x equals negative 2, and we have x is equal to 4. And so to find our factors, we need to set the side of the find factored form, we need to set the right side equal to 0. So if we add 2 to both sides of this equation, we have x plus 2 is equal to 0. So this is going to be one of our factors, x plus 2. And for the right one, if we subtract 4, we get x minus 4 is equal to 0. So our factored form is going to look something like this. F of x will look exactly like this. A times quantity x plus 2 times quantity x minus 4. So we really need to find out what A is. And to find out what A is, we're going to use this point 1 comma 5. So this 5 is going to replace this f of x, and this 1 is going to replace this x here, and also this x over here. So we do that, we have 5 is equal to a times we have 1 plus 2, right? And just replace with 1 times quantity 1 minus 4. And so further simplifying, 5 is equal to a, and we have 3, 1 plus 2 is 3, and 1 minus 4 is going to be negative 3. So this is going to be 5 is equal to negative 9a. And divided by negative 9, a is equal to negative 5/9. Okay? Well, we're going to just see how close we are on this deal. What I'm going to do is we're going to plot these points. And so our function is going to be f of x equals negative 5/9. And in factored form, we're going to have quantity x plus 2 times quantity x minus 4. So let's just see what this thing looks like. Let's go to a calculator. We're going to go to stat edit, and enter all these points for this new one. So we have negative 2.3, enter, negative 1, enter, 0, enter, 1, enter, 2, enter, 3.7, enter. This is as accurately as I can read this from the graph that I have. So we have here negative 1.3, enter, 3, enter, 4.5, enter, 5, enter, 4.5, enter, and finally 1. So that looks good. The plotted points will look like this. We have that blue equation right there. Let's go ahead and enter the factored form that we have. I'm going to go turn this one off. So we have negative 5/9 we have times quantity x plus 2, x minus 4. So we have x plus 2, x minus 4, close parentheses. Let's see what this looks like. So quite a good match. Okay, so that's going to be right. Again, I'm going to be very liberal. If you happen to use another method to somehow graph this parabola, that's you're going to have some mercy. So it's going to go like this. Again, I'm not looking for perfection on that sketch of the graph, but it'll look something like this. And so we know that this is quite a good model right here. And if you end up somehow doing it like we did this other one over here, or finding sketch somehow, that'll be okay. Here's our model here for this one. Forgot to box this one in here. Okay, let's go over to next problem. The graph of the quadratic function has vertex at 4, negative 5, and opens upward. Can each of the following points lie on the graph? So for this, my recommendation is just to kind of draw a sketch of what's going on. So if we draw an XY coordinate plane like this, and we go to a vertex of 4, negative 5, so 1, 2, 3, 4, and negative 5 down here. 3, 4, 5. So we have, and we're opening upwards, so I'm going to put 4, comma, negative 5. And so we are opening upward somehow. So any point here has to lie above this. Now the first one, A, is going to be 5, negative 6. So I'm going to do that in red. So that'll be 5 and negative 6. So it's going to be right here. Is that going to be possible? No, that's not possible. So this will be no, because that's below. We have to be above this dashed line. Negative 6, comma, negative 1. So for this other one, I'm going to use purple. Right? So negative 6, comma, 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Negative 1 is going to be right over here. Is this point possible here? Yes, it is, because it's going to be possibly up like that, right? So yes, for the second one. 1, comma, negative 5. Well, at 1, comma, negative 5, we go to 1, but we're down 5. Okay, we are horizontal with this vertex. So that's not going to be a quadratic function because you just have a horizontal line. So that'll be no for part C. Next, write the quadratic function for the parabola that has an axis symmetry of x equals 1 points, negative 2, comma 5, and 2, comma 3, and opens upward. Then sketch a graph of the function. So we have an axis symmetry of x equals 1. So here it is. X is equal to 1. Well, here's a situation where we have an axis symmetry and 2 other points. So we're going to have, let me get a skinnier pen. Okay, what we have is here's our standard form, f of x equals a times quantity x minus h squared plus k. And we're going to use this in 2 instances. We're going to get 2 equations. We have 2 points. So we're going to have here for the point on the left, which is going to be negative 2, comma 5. And on the right, we're going to do the same thing, but for this one, which is for 2, comma 3. Okay, working the one on the left, we have, well, h is going to be equal to 1. So h is equal to 1. So we have on this left one, 5 equals a times, well, we have negative 2 minus 1, because 1 is h, squared plus k, which we do not yet know. And then we can continue to solve this. We have 5 equals, well, negative 2 minus 1 is negative 3, and negative 3 squared is 9. So we have 9a plus k. Okay, that's good, but not enough to solve. For point 2, comma 3, we have 3 is equal to x, which is 2, minus 1 squared plus k. And so we have 2 minus 1 is 1, so 3 equals a plus k. And now we can solve. And to do that, we can just subtract. So I'm going to just bring this one, 3 equals a plus k, put this right underneath. So 3 equals a plus k, and subtract out. So we get 5 minus 3 is 2, 9a minus a is 8a, and then we have k minus k is 0. So we have 2 equals 8a. So if we divide by 8, we have a is equal to 2/8, which is equal to 1/4. And now we can find we can plug in 1/4 for A, so I'm going to go right up here and plug in for this A. So 3 is equal to 1/4 plus K. And so how many fourths do we have in 3? We have 12 fourths equals 1/4 plus K. If we subtract 1/4, we have K is equal to 11 fourths. So our equation is going to be f of x equals A, which is 1/4. We have x minus h, which is h is 1, squared, plus k, which is 11 fourths. And the last thing we can do, well, maybe not the last, we're going to sketch 2, but let's go to calculator. So we have clear these out. We have 1/4. Oops, I put 4/4. Need to do that. 1/4. Oops, what is this thing doing here? 1/4. There we go. I don't know what happened there. I'm going to put quantity x minus 1 squared, and then we have plus 11 fourths. Was that right? 11 over 4. So we graph this. Let's just graph this right here. And we have the other points. We're going to go, I'm going to go turn this plot off to get a cleaner look. And so we should see 1, 11 fourths. And what else should we see? We should also see, we should see 1, 11 fourths right here, which is almost 3. It's like 2.75. And we should also see -2, 5. So we go to -2, we should get -2, 5. Okay, so that should be what the thing looks like. And then we'll have, because of symmetry, we would have 4, 5. Right? So it looks something like this. Let's go to table view. We go to second graph. We have -2, -5. That checks out. We have 1, 11 fourths. That is our vertex. And finally, we have 4, 5. So this is what the thing looks like. We have look like this. Not very artistic. Again. Okay, let's see. It looks something like this. Not looking for perfection on those graphs. Okay, the last one in this preview is going to be a suspension bridge problem. We have cables on either side of a pedestrian bridge or in the shape of a parabola. So we go here. The towers support cables 150 feet apart or 50 feet high. So here we have the towers here, and they are 50 feet high. And we have, I'm just going to put out an XY coordinate plane like this. So what we have is we have the point 0, 0, and we have a suspension bridge that we have a parabola that's suspended between these two towers and is going up like this. And that's our point 0, 0. We have 50 feet high, so this one right here is 0, 50. That's our point right here. And 150 feet apart. So right here we have 150, comma 0. And right up here at the top, we have 150, comma 50. And right down here, the cables are at a height of 6 feet midway between the towers. So midway between the towers, half of 150 is 75. So we have 75, comma 6. So that is a vertex. So we can use our vertex in one other point. So our, let me just give you a pin here. What we have is f of x is equal to a times quantity x minus h squared plus k. Well, we know our vertex is going to be 75, comma 6. So f of x is equal to a times x minus 75 squared plus k, which is 6. So we can take any of these points to make this work out. I'm going to take this one right here, this 0, comma 50, because that's just one other point. And so f of x, which is 50, is equal to a, and then x is 0, so we have 0 minus 75 squared plus 6. And now if we take, if we subtract 6 on both sides, we have 44 on the left side is equal to negative 75 squared. So we have in our calculator negative 75 squared, and for that we get 56.25. A. Okay, so if we divide by 56.25, so I don't know if we're going to get, that may be as close as we can get it here. May not simplify. So we have 44 divided by 56.25. So we get the same fraction here. So I'm just going to leave this in fraction form. 44 divided by 56.25. So our equation is going to be f of x equals 44 over 56.25. We're going to have times quantity x minus 75 squared plus 6. And now we can test it in our calculator. And if we have all these 3 points, the vertex down here below, and these other 2 points at the top of each tower, we'll know that we are correct, and so we could use that. So let's do that. 44, 56.25. Down below 56.25, and we have x minus 75, so 70. I'm going to do control insert 5, 75, and over here we're going to have plus 6. So we should get everything there. And if we go to table view, well, let's do this. We're 75 apart. I'm just going to, we're going to table start there. We're going to go each at 75. We should see everything we need. So we have 0, comma 50, check. We have 75, comma 6, which is our vertex, and we have 150, comma 50, check. So that is all good. So that is a good equation and says, what is the height of a cable at a point that's 30 feet from the center of the bridge? Well, here looks like it's the center of the bridge, right? That's going to be our center. And 30 feet from the center of the bridge, that's going to be at 75 plus 30 equals 105. So 105 feet out, what is that height going to be? Well, it's going to be 105, comma, question mark. So we're going to plug in 105. So we'll say F of 105 is going to be equal to our answer. Well, let's go over to our calculator again. And I'm going to go over here and put in, here we already have this value, so I'm going to put in 105 storage x. Okay, now we're going to just type in the equation. We know it's going to be A, and A is 44 over 5625 times quantity x minus 75, close parentheses, squared, plus 6. Okay, enter. So we get 326 over 25, and what do we do to get a decimal approximation? No, that's the wrong one. Okay, what I'm going to do is go to math, decimal. I guess if you have it in fractions, so 13.04 feet high. Feet high, or above. Yeah, that's how high the cable is. So that's going to be our answer here. So that's going to be it. So test covers quite a bit. Good luck, and as always, thanks for viewing.